Batteries are one of the most critical components in any battery-powered electric vehicle. Battery packs are analogous to the engine inside conventional vehicles. Better the engine, the better the performance of the vehicle. Similarly, a better battery pack means a better performing electric vehicle. So it is no surprise that every bit of news about Tesla's new 4680 battery is sure to stir excitement for electric vehicle fans. The excitement is further supplemented by the fact that Elon Musk had announced on Battery Day last year that the new 4680 cell-based battery pack would be offering 5 times more energy, 6 times more power, and an increase in range by 16%. But before we can really appreciate what Tesla is trying to achieve with their new 4680 battery pack and how it will dominate the electric vehicle market, let us briefly look at previous and current battery cells Tesla has been using in their electric vehicles. The brain behind Tesla's battery technology was J.B. Straubel. Straubel had a master's degree in energy engineering from Stanford University, and from the beginning he was just infatuated by batteries and energy storage devices. He and Elon Musk first met in 2003 for lunch. During the historic lunch, Straubel mentioned his ambitions to create a lithium-ion battery pack that could last for 1,000 miles on a single charge. Elon was so inspired by his ambitions and his genius that he later invited Straubel to join his newly incorporated electric vehicle company, Tesla Motors. Straubel was the 5th employee at Tesla and named a co-founder at the company. Straubel would spend 15 years as Tesla's chief technology officer. Tesla owes a lot of its success to Straubel's genius and ingenuity. Straubel, when he first joined, got straight to work on designing the battery pack to be used by future Tesla vehicles. His aim was simple. He wanted something that would give Tesla electric vehicles a longer range and be safe to handle and use. He came up with the 18650 lithium cell. It's called that because the 18650 cell is 18mm in diameter and 65mm in length. In a 2006 paper written by Straubel, he explains his 18650 designs. We started our design by purposely picking a small form factory battery cell. Due to its small size, the cell contains a limited amount of energy. If a failure event occurs with this cell, the effect will be much less than that expected from a cell many times larger. The 18650 powered Tesla's first electric vehicle, the Roadster, that was released in 2008. It came with a range of about 245 miles on a single charge. This completely blew away automakers all over the world. This kind of range was just unheard of in battery electric vehicles back then. For the first time, a fully electric vehicle was posing serious competition to other automakers. Not only that, but real-life performance tests also showed that its performance was comparable to that of many gasoline-powered sports cars. The Roadster could accelerate from 0 to 60 miles per hour in less than 4 seconds and could reach a top speed of 125 miles per hour. This was all possible due to Tesla's in-house design of using large stacks of smaller cells instead of a few large cells. The 18650 powered Tesla vehicles until the Tesla Model 3 came out. Since then, Tesla has been using the much larger 21mm wide and 70mm long 2170 cells. And now Tesla is looking to shift to their latest 4680 cells. This cell was announced back by Elon Musk at the Battery Day event held last year. Right from the start, Elon had impressive performance numbers to boast about. During the presentation, he announced that the new upcoming 4680 cell-based battery pack would be offering 5 times more energy, 6 times more power, and an increase in range by 16%. So, how do the 4680 cells aim to live up to these numbers? Well, Tesla has made some interesting design choices. First, from the name, you can tell the cell is larger than the previous 2 battery cells that Tesla has been using, measuring at 46mm in diameter and 18mm in height. Tesla has decided to stick to their cylindrical cell profile. This contrasts with other electric vehicle automakers that use the rectangular cell pack. But the 4680 is not just a larger version of the previous cells. Tesla has improved the internal structure of the cell as well. They used laser-patterned shingles inside the battery to make the shorter path for the electrons to travel to improve efficiency. So even though you have a larger cell, you have a battery with more power coming both in and out, resulting in shortened charge time. According to Tesla, this has reduced the electrical path by 5 times. A 5 times reduction in electrical path means that energy flow per second is increased by 5 times. This can explain Tesla boasting about 5 times more power than previous cells. Another important design choice Tesla chose is using a tabless cell design. The tabs in a cell are small metallic components welded onto the electrodes. In fact, tab manufacturing for a cell is the most challenging part of cell manufacturing. If done wrong, it can greatly affect the reliability and performance of the cell. Manufacturing defects like welding burrs can separate the anode and the cathode and end up causing a short circuit, so tabs do add another point of failure into the cell. What Tesla is trying to do with their tabless design for the 4680 is to get the same conventional tab functionality by using a conductive portion that runs along the electrode. By using this tabless design, the maximum distance that electrons should travel is the height of the electrode rather than its length, as in the case of a conventional tabbed electrode. The height of an electrode is only 5 to 20% of its length. Hence, the ohmic resistance that the electrons face, and consequently, the heat that is internally generated, will reduce significantly. Reduced ohmic resistance comes with another great advantage. The cells will generate less heat, well, because of less resistance. Additionally, another advantage is that the current is distributed uniformly across the table's electrode. This reduces the likelihood of local forming hotspots with large overpotentials that can damage the battery. So, we have talked about shorter electrical paths, less heat generation, and avoiding the complications of using a tab design. But what does it all mean for the end consumer? The Tesla drivers care less about the engineering ingenuity and more about the performance of their electric vehicles. Well, everything we are hearing sounds like the 4680 will make Tesla vehicles a force to be reckoned with. The new 4680 cells will improve the power-to-weight ratio of the cars, streamline manufacturing processes, and lower the cost to manufacture. A higher power-to-weight ratio means faster acceleration and more power available to the driver. The table's design will allow Tesla to streamline their manufacturing process and reduce points of failure in the cell packs. This has the added benefit of reducing manufacturing costs as well. Tesla claims the battery pack, along with other several new technologies, could combine to reduce costs by almost 50%. In fact, Tesla is hoping that these new batteries will allow them a $25,000 Tesla vehicle. If Tesla can achieve that, it will go a long way toward making electric vehicles affordable and more accessible. No electric car manufacturer can come close to this price, not with the current technology. But for now, Tesla is planning to use the 4680 battery cell in their upcoming vehicles, the Tesla Semi and the Tesla Model Y. Tesla has been running a pilot factory for the new battery cell in Fremont, where CEO Elon Musk has been guiding reaching a production capacity of 10 gigawatts per hour by the end of 2021. According to the Q2 2021 financial results that Tesla released, we have successfully validated the performance and lifetime of our 4680 cells produced at our Kato facility in California. We are nearing the end of manufacturing validation at Kato. Field quality and yield are at viable levels, and our focus is now on improving the 10% of manufacturing processes that currently bottleneck production output. While substantial progress has been made, we still have work ahead of us before we can achieve volume production. Internal crash testing of our structural pack architecture with a single-piece front casting has been successful. In short, Tesla has made huge progress since they announced the 4680 cell last year, but they still must achieve mass-scale production capabilities. Tesla even had to push back the debut of the 4680 by cancelling the Model S Plaid Plus, which would have been the first Tesla vehicle with the 4680 cells. But once Tesla is successful at scaling their battery production at the Kato facility, they are planning to deploy high-volume battery production at the Gigafactory in Texas and the new Gigafactory being built in Berlin. Tesla is hoping to achieve battery production goals of 100 gigawatts per hour by 2023 and 3,000 gigawatts per hour by 2030. Tesla has from the start differentiated itself from other electric vehicle manufacturers by their proprietary battery technology. Tesla's battery technology is one of the main reasons Tesla electric vehicles are so popular, and to date, Tesla is the market leader in the electric vehicle sector in the United States. And with the 4680 battery cells, Tesla is planning to stay ahead as more and more automakers enter the electric vehicle market.